On page 25, they talk about muscular development and strength. In the elementary school years, elementary, their muscular strength increases linearly with their chronological age until adolescence. What does that mean? So, as they grow from second grade to third grade to fourth grade to fifth grade, it's kind of like a line. It actually goes evenly with it until they get to adolescence. And then when puberty sets in, that's when you see a rapid increase in strength occurring. So I want you to know they compared the differences in their lower body strength for those students ages 7 to 17. They took the differences in strength between the sexes and they adjusted it for the height because you have some real tall, some short. So they adjusted it for the height. What they found is this that's so important. There's no difference in lower body strength from ages 7 to 17. From ages 7 to 17, there's no difference in strength. So if everything else was equal, the body, the legs, and the running and such, there's no difference. But when the same adjustment between the sexes was made for upper body strength, I want you to know this is when the boys have been found to have more strength in their upper extremities and their trunk compared to the females. And this is so true. Look how we females get weaker in our upper bodies, in our arm strength, push-ups, pull-ups, whatever it may be for upper body strength. We do less and less and less as we get closer to age 17, and the boys get stronger, stronger, stronger. So what is all this saying? The boys and girls can participate on a somewhat even term in activities demanding leg strength, especially if their size and mass are similar. But if you're comparing upper body strength, the boys have an advantage. So, when you're pairing children for activities, you do not want to partner students with someone considerably taller and heavier or more mature and therefore stronger. So if we have 4 or 5 people who are taller in grades 2, then we want to try and have, or if we're playing a game and you need 2 teams, then you do not want all 5 tall students on the same team. You want to put 2 or 3 on one team, 2 or 3 on the other. You want to make sure to mix them up, and so you can have an evenly matched team. Muscle fiber type and performance. I want you to know that we as humans are genetically predisposed. We have a genetically determined number of muscle fibers in our body. Our muscles are going to get bigger and larger when each muscle fiber increases. So the size of the muscle is determined first by the number of muscle fibers, and second, by their size. I like to compare it to uncooked spaghetti noodles. Those hard spaghetti before it's cooked, and you have it in a plastic container bag when you buy it, or you put it in a Tupperware container. So how many of those hard plastic noodles in that plastic Tupperware container do you have? Some of us, we're genetically predisposed to have a larger number of muscle fibers within a muscle. Consider that Tupperware container a muscle. And depending on the size of that Tupperware container would determine the number of muscle fibers within that muscle, within that container. So I don't know if you ever thought about it, but genetics has a lot to do with our muscles. Our skeletal muscles, we have 2 types. We have fast contracting fibers, which we call fast twitch, and we have slow contracting, slow twitch. What does that mean? whenever you bend your elbow and bring your hand towards your shoulder, the muscle fibers in the front are contracting. Those are your biceps of your upper arm. And the muscles in the back of your upper arm are elongating and doing the opposite of contracting. Well, how fast does that happen? Or how slow does that happen? We're mainly talking about the legs, okay? But when you take a step and you extend your foot to take a step, okay, the front part, the muscles in the front of your leg are contracting, the muscles in the back of your leg are elongating, and then when you pull and the opposite leg goes forward, that back leg, now the back muscles of the back leg are contracting and the front muscles are elongating. So the percentage of how much fast twitch versus slow twitch fibers we have, it varies from muscle to muscle among us individuals. I want you to know most individuals possess a 50-50 split, which means half of the muscle fibers in the muscle are fast twitch and half of the muscle fibers are slow twitch. But some people have the 60-40 ratio in either direction. 60% fast twitch, 40% slow twitch, or vice versa. So this is where you find some individuals are speedsters and can run the 100-meter dash faster. And then there's others who excel in endurance running. Those have the 60% slow twitch. So how does this affect us in PE? What is the significance of this ratio of muscle fiber type? I want you to know your slow twitch fibers that have that rich supply of blood and related energy. This results in slow contracting, fatigue resistant. So what does that mean? I want you to know they're well suited for endurance, aerobic activities like the mile run, your distance running and track, 5K runs, okay? Whereas your fast twitch, they have bursts of intense activity, and they're subject to rapid fatigue. They can go fast for a short period of time, but then they get tired out real quick. So these fibers are well suited for short distances or for pull-ups, standing long jump, shuttle run, the short distances, the 50-meter dash, 100-meter dash, okay? But surprisingly, what you need to understand is this. The elementary age children who do best in activities requiring the fast twitch fibers, they also do well in distance running. Why is that? This is what you need to understand. The muscle fiber metabolic specialization does not occur until adolescence. So this is why they do well in both types of activities. At adolescence, that's when you see the increase in testosterone at that onset of puberty. Then you start comparing, you can see the difference. So a child who does poorly in elementary school may do quite well during and after adolescence when a higher percentage of those slow twitch fibers have aided in aerobic activities, or a higher percentage of fast twitch fibers help them in team sports in which they need quickness and strength. So at the elementary school age, we don't know yet if they're going to be good in short distances or long distances. It's not until the puberty kicks in that they have that specialization, if there is, the 60-40. Relative strength and motor performance. We know strength is an important factor in performing motor skills. Another study was done to identified weight factors contributing to the child's motor performance. One of the factors that was most important was their strength in relation to their body size. Strength in relation to their body size, and we call that relative strength. Strength in relation to their body size. They found that high levels of strength in relation to the body size helped predict which students were most capable of performing motor skills. They found the fourth ranked factor in the study was dead weight or body fat, and that had a negative impact on their performance because it reduced their relative strength. So, what are we talking about here? Think about it. If you've ever seen somebody on a powerlifting team, your ectomorphs or your you got ectomorphs, mesomorphs, and endomorphs. So the ectomorphs are your small ones, and they don't weigh very much, but they're not expected to lift as much weight compared to your mesomorphs and then your endomorphs. Those that have a lot more body weight, they're expected to lift more compared to those skinnies or those that don't have the body weight. So I want you to know this lack of strength in relation to body size causes overweight children to find a strength-related task, such as push-ups or pull-ups, much more difficult than the task would seem to be for a normal weight child. And we've talked about this. It is very difficult for an endomorph to do push-ups or pull-ups because they have to lift a lot more weight compared to those that have or are your ectomorphs. So what is this saying? We need to vary and personalize the workloads to ensure that all the children find success in any strength-related activity. Again, if you're going to do push-ups or pull-ups or sit-ups, especially with the 4th or 5th grades, is when you start to see more of the specialization of the endomorphs compared to mesomorphs and ectomorphs. You may want to do time rather than number of push-ups or sit-ups for any strength-related activity. Aerobic capacity. Children are not little adults. So true, and we need to understand this. What is maximal aerobic power? Maximal aerobic power is a person's maximum ability to use oxygen in their body for metabolic purposes. This oxygen uptake, and if all other factors are equal, determine the quality of endurance that this student will be able to exhibit. So maximal aerobic power is very closely related to lean body mass, which helps explain why we have the differences in performance between boys and girls. When you take that maximum oxygen uptake and you adjust it per kilogram of body weight, there's very little change for boys. In fact, there's no increase at all, and a gradual decrease for girls as they reach maturity. And this decrease in girls is due to the increased body fat and a decrease in lean body mass. That's just human nature. So 4 out of 5 adults interested in increasing their endurance performance will improve in response to physical training. The results have shown that training caused little, if any, increase in aerobic power in those prepubescent children. So what actually happened is they became more efficient in the mechanics of how to run. Another theory is that the young children may be active enough so the training effects didn't really affect them. So I want you to know, children, this is very important that you understand this for test purposes as well as just to know it for your own benefit. Children demonstrate a rapid recovery rate after strenuous exercise. If you and I were to go run as fast as we can for 100 meters, we would be huffing and puffing. But these kids, they recover rapidly after that strenuous exercise compared to adults. So we as teachers should use a child's rapid recovery rate to the full advantage. What do I mean by that? I want you to know we should have exercise bouts of about 30 seconds and intersperse that with a recovery period of maybe stretching and a non-locomotive movement. This is called interval training. It's very effective with children because it allows them to exercise aerobically and then recover with the stretching or non-locomotor. So they can continue to go. This intermittent activity, this interval training, this is what we want to do. Have them run for a little bit, then maybe do some non-aerobic activity, which is stretching or any non-locomotive movement. So when you're designing your fitness activities for your lesson, you want to keep this in mind, this interval training. Let's look at overweight children and the actual physical performance. As I've been saying already, the overweight children, they seldom perform on par with leaner children when they're doing physical activities. The overweight child requires a higher oxygen uptake to perform the same task. It takes them more energy, more oxygen for an overweight student to jog or walk at the same speed as an ectomorph or a leaner person. So we cannot expect them to do the same task at the same speed or the same rate. We need to understand as teachers that if we ask an overweight child to run as fast or as far as a normal weight child, that is very unrealistic. So I want you to know we need to adjust the student workloads on time rather than distance. So when we're talking about any strength activity, we want to do time. And now I want you to know when we're talking about distance, if we have endomorphs in our class, we cannot expect them to run a lap, 2 laps or whatever in the same amount of time compared to an ectomorph and a mesomorph. So all children should not be required to do the same workload. The intensity of the activity should be secondary to the amount of time the student is involved in performing that type of moderate activity.